Alright, welcome to the Algebra 2K test review for Quadratics 2. Alright, so let's get started. On numbers 1 and 2, it just says multiply, simplify completely. Alright, so I'm going to multiply this together. We got 10x times 2x, which is going to be 20x squared. 10x times 5, which is plus 50x. Then we got 3 times 2x, which is 6x. And then we got 3 times 5, which is 15. Alright, then combine your like terms. You end up with 20x squared plus 56x plus 15. Alright, so then on number 2, alright, same thing. We got 3x minus 11 squared, so it's two of these being multiplied. Alright, then same thing. 3x times 3x would be 9x squared. 3x times negative 11 would be negative 33x. And then here we got negative 33x again. And then negative 11 times negative 11 is plus 121. And then combine your like terms. We get 9x squared minus 66x plus 121. Alright, so now for the next part, factor completely. Alright, so let's look at number 3. 21x squared minus 25x minus 4. So first, always check for GCF. On this one, we have no GCF other than 1. So let's split the middle term. So we have 21 times negative 4. That's going to be negative 84. And then we got to find two terms that multiply to negative 84, add up to negative 25. Right, then you could always do this. Negative 84 divided by x. And then find two things that multiply to negative 25. Right here we have negative 3 and 28, but those make a positive 25, and so right here 3 and negative 28. Alright, so we're going to use those two numbers to split the middle term. Alright, so we got 21x squared plus 3x minus 28x minus 4. Alright, so now take out a GCF from each side. So from this left side, we could take out a 3x, which leaves you with 7x plus 1. On the right side, it's leading with the negative. It's leading with the negative, so take the negative out with it. So we're going to take a negative 4 out. If I divide this by negative 4, we get a positive 7x and then a positive 1. So since we have the same thing on both sides in the parentheses, that means we did everything correctly. Now whatever you took out from each side, combine them. That's going to give you one of your factors. So 3x minus 4, and then your second factor is the one they both shared, which was 7x plus 1. Alright, so those would be your two factors. Alright, so let's look at 4. 3x cubed plus 12x squared minus 63x. Alright, so on this one, you can factor out a GCF of 3x. Alright, so if I were to divide all these by 3x, we would get x squared plus 4x, and then minus 21. Alright, so then this GCF, that's going to be one of your factors at the end, and then all we have to do is just factor this. Alright, so on this one you don't have a value, or you have a value not greater than 1 in front of the x squared. Alright, so it's just x squared plus 4x minus 21. So whatever multiplies to negative 21 adds up to 4 would help us get the factors. So the two numbers that multiply to negative 21 and add up to 4 would be 7 and negative 3. Alright, so our two factors are x plus 7, x minus 3. And then don't forget to bring this 3x back down, because that's going to be one of your factors. Alright, so 3x, x plus 7, x minus 3. And again, 7 times negative 3 give you a product of negative 21. 7 minus 3 give you a sum of 4. Alright, so now number 5, let's split the middle again. So 4 times negative 3 would give you negative 12. Alright, so we got to find two numbers that multiply to negative 12 and then add up to negative 4. Alright, that would be negative 6 and positive 2. So I'm going to use those two numbers to split the middle. Alright, so we got 4x squared, let's say plus 2x minus 6x minus 3. Alright, so sometimes the order you put these in makes taking out the GCF a little bit easier. So on this one, putting the 4x squared, or putting the 2x with the 4x squared makes that easier to take out a GCF. Also minus 6x minus 3, same thing, it's easier to take out a GCF. So 4x squared plus 2x has a GCF of 2x. If I were to divide this by 2x, we would get 2x plus 1. And then on the right side, it's leading with the negative, so take the negative out. We're going to take out GCF of negative 3. And then if I were to divide this by negative 3, we would get positive 2x, negative 3 over negative 3 plus 1. And again, make sure these are both the same. If they're not the same, that means you messed up somewhere here or taken out the GCF. So whatever you took out, combine them. I took out a 2x and a minus 3. So that makes 2x minus 3 for one of the factors, and then the second factor is whatever they both shared, which was 2x plus 1. Right, so then let's move on to 6. So again, first step is to always check for GCF. So on 6 we have a GCF of, looks like it's 4. Alright, so I'm going to take out GCF of 4, and then you get 3x squared minus 2x minus 5. Right, so another way you can factor is by guess and check. So for this one, I'm going to use guess and check. So we got a GCF of 4 on the outside, so just bring it down when you find the factor to this. So we have two factors. We have 3x squared. So if you want to get a 3x squared, you need a 3x and an x. Right, now when you so if you were to multiply the outside, so 3x and then whatever you put here, and then multiply the inside, they should add up to negative 2x. And the numbers you're putting here are numbers that add up to negative 5. Alright, so let's think of a combination that would work to give us negative 2. So for this one, I'm thinking we could do plus 1 here, and then minus 5 here. So let's just make sure this adds up to negative 2x. So right now the 3x and the x check off the 3x squared. Negative 5 times 1, multiply to negative 5. Now if I multiplied 3x and 1, you get 3x. If I multiply negative 5 and x, we get a minus 5x. which would give us negative 2x. So that checks off. So that's going to be our two factors. So let me just write that again. 4, 3x minus 5, x plus 1. So those are going to be your two factors. Alright, so now let's look at 7. Alright, so on 7 we have 25x squared plus 40x plus 16. So let's see, do you have a GCF? So no GCF between 25, 40, and 16. So now let's split the middle term. So 25 times 16, that would be 400. Then you got to find two numbers that multiply to 400, add up to 40. That would be 20 and 20. So now use 20 and 20x to split the middle. So we got 25x squared plus 20x plus 20x plus 16. So now let's take a GCF out from each side. 25x squared plus 20x has a GCF of 5x. Alright, so if I were to divide these two by 5x, I would get 5x plus 4. Now on the right side, 20x plus 16, those would both have a GCF of 4. And if I factor out a 4, you get 5x plus 4. Alright, so both of these factors are both the same, so this trinomial is a perfect square trinomial. Alright, so this is a perfect square trinomial. That means both of the factors are the same, and you could also write this as 5x plus 4 squared if you wanted to. Alright, so let me just put this off to the side. 5x plus 4 squared. So this is just another way you could write it. So again, you could write it this way, or you could write it this way. Alright, so now on number 8, there's no number in front of the x squared, so all you have to do is find two numbers that multiply to 68, add up to negative 21. Alright, so let's find some numbers that multiply to 68 and then multiply to negative 21. So 68 divided by x, go to the table, find something that adds up to negative 21. Alright, so we have 4 and 17, but those add up to positive 21, so it should be a negative 4 and a negative 17, so right there. Negative 4, negative 17, if you add them together, you get negative 21. Alright, so those would be your two factors, x minus 4, x minus 17. Minus 17. Alright, so we got more examples. Number 9, 36x squared minus 100. So check for GCF. So 36 and 100 could both be divided by a 4. So let's factor out a 4. Alright, if I factor out a 4, we get 9x squared minus 25. Alright, 9x squared and 25 are both perfect squares. They're both separated by a minus, so we're going to use dots on this. So we got two sets of parentheses. One has a plus, one has a minus. 9x squared, you would get that with 3x times 3x. And then to get negative 25, you would need plus 5 times negative 5. So these would be your factors. 4, 3x plus 5, 3x minus 5. And so now on 10, this is going to be another dots problem. X to the power of 8 minus 1. These are two perfect squares separated with a minus. So to get x to the power of 8, we need x to the power of 4, x to the power of 4, plus minus 1, 1. And then whenever you do dots, always make sure that everything is factored completely. This is factored completely, but this one you could factor a little bit more. So x to the power of 4 minus 1, this is another factoring using dots. So this would give you x squared plus 1, x squared minus 1. And then you actually do have another dots here. X squared minus 1 would be another dots. You would get x plus 1, x minus 1. Alright, so these would be your factors for number 10. We have x to the power of 4 plus 1, x squared plus 1, and then x plus 1, x minus 1. Alright, so this one had 1, 2, 3 dots in it. Alright, so now let's look at number 11. So again, always check for GCF. 2x squared, 162x to the power of 6. This one, you can take out a 2x squared. Right, so let me do this one in a pen. So 2x squared, which leaves you with 1 minus 81x to the power of 4. Alright, so now this is going to be another set of dots. Alright, so from this, you would get 1 plus 9x squared, 1 minus 9x squared. And then this 1 minus 9x squared, that would be another dots, because 1 and 9x squared are both perfect squares. You would get 1 plus 3x, 1 minus 3x. Alright, so your factors end up being 2x squared, parentheses 1 plus 9x squared, and then 1 plus 3x, 1 minus 3x. Alright, so this is another one with 3 dots. So dots here, and dots there. Alright, then number 12 is just the same as number 4. Alright, so now number 13, that's going to be another dots. Alright, so these are two perfect squares separated with a minus. Alright, if something's being squared, that means it's the same thing being multiplied by itself, and you could square root that, and you just get whatever being squared. Alright, so we got x minus 1, or x minus y squared minus 4a plus b squared. Alright, so let's set up the dots. Alright, so from x minus y squared, if you want to get x minus y squared here, you need x minus y, x minus y. Alright, plus, if you want to get 4a plus b squared, that would just be 4a plus b. Alright, now be careful on this one, minus 4a plus b. Alright, this minus has to get distributed to the 4a plus b. Alright, so on this one, the plus doesn't affect anything. This would just be x minus y plus 4a plus b. But then on this one, you get x minus y minus 4a minus b. Because you have to distribute the negative here. This minus right there changes to 4a plus b. Alright, so now on 14, let x equals c plus d. Alright, so let's replace the c plus d with an x so it makes it easier to factor, and then once you factor it, just replace it back with c plus d. Alright, so this is just x squared minus 2x minus 63. Alright, so if we were to factor this, you would get x minus 9, x plus 7. So negative 9 times 7 is negative 63, negative 9 plus 7 is negative 2. Now replace the c plus d back in here. So c plus d minus 9, c plus d plus 7. So this would be the factor. Alright, so now for the next section, same thing. We're going to factor, but we're going to solve. Alright, so if you see the word solve, that means you have to make sure that the expression is equal to 0 and solve for x. So 15, 16, 17, 18, we're going to solve each quadratic equation by factoring. Alright, so on 15, first check for GCF. 2, 8, and 6 both have, or all three of them, you can take out a factor of 2. Which leaves you with x squared plus 4x and then plus 3. Alright, so this 2 isn't going to do anything. You could actually divide the 2 to both sides, and then the 2 would just reduce to a 1. 0 divided by 2 is just 0. So you actually just have x squared plus 4x plus 3 equals 0. Now let's factor this. We just have to find two numbers that multiply to 3, add up to 4, which would be x with positive 3, x plus 1. Alright, so x plus 3, x plus 1, and then set them each equal to 0 and then solve for x. So x plus 3 equals 0, x plus 1 equals 0. Our two solutions are going to be x equals negative 3, x equals negative 1. Alright, so then let's look at 16. Right now we can't solve this because it's not set equal to 0, so we're going to subtract the 144. We get x squared minus 144 equals 0. These are two perfect squares separated with a minus, so this is going to be a dots. Alright, so this is going to be x and x plus minus 12 and 12. Alright, so then set each one equal to 0. And then you get x equals negative 12 and x equals positive 12. Alright, you could also solve this one using the square root method. On 17, x squared minus 21x equals 0. So remember, always check for a GCF first. So right now, this isn't a trinomial. You also cannot use dots because 21 is not it's not a perfect square. So let's factor out a GCF, which would just be x. So if I take out an x, we're left with x minus 21. And then that's all we could do to it, so let's just solve for x with our two factors. So we got x equals 0, and then for the second one, x minus 21 equals 0. Alright, so x minus 21 equals 0, just add the 21, so x equals positive 21. And x equals 0, those would be your two factors. Alright, so now on 18, again check for GCF. 12, 5, and 3, they do not have a GCF other than 1, so let's split the middle term. So 12 times negative 3. That would be negative 36 And then we got to find two numbers that multiply to negative 36 and add up to 5. Alright, so the two numbers that would do that would be positive 9 and negative 4. So we're going to use those two numbers to split the middle. Alright, so we got 12x squared minus 4x plus 9x minus 3 equals 0. So on the left side, take out a GCF. Well, you could take out a GCF of 4x. If I take out a factor of 4x, we're left with 3x minus 1. On the right side, 9x minus 3, they would have a GCF of positive 3. And if I divide that by 3, you're left with 3x minus 1. So then whatever you took out, combine them. So we got 4x plus 3, that's going to be one of your factors, and 3x minus 1. Now set them both equal to 0, and then solve for x. Alright, so if I solve this for x, you should get x equals negative 3 over 4. This is going to be x equals positive 1/3. Alright, so that's page 1. So that was all factoring. Alright, so then 19, 20, 21, 22, 23, 24. This is going to be simplifying each square root. Alright, so let's look at number 19. So let's try to break down 45 with a prime number and then see if you can get a perfect square for the other number. So for this one, let's see, you could break up 45 with 5 and 9. Alright, if I were to take the square roots of those, you could only take the square root of square root of 9, which would give you a 3. So then you got 3 times 3 times the square root of 5. 3 times 3 makes 9, and then times the square root of 5. So that would be that one. Alright, so now on 50, you could break this up with a prime number of 2, and it's going to leave you with 25, or 2 times 25 make 50, and then if you square root both of them, the only one you could square root is 25, so then you got 5 times the square root of 2, and then that's just 5 square root of 2. Alright, so then on 21, you could break 18 up with 9 and 2. If I square root the 9 and the 2, the only one that could get square rooted is the 9. So I have 10 times square root of 9 times square root of 2, and then, yeah, so square root of 9, we know that's going to be 3. And then square root of 2, that's not a perfect square, so it's just square root of 2. So we got 10 times 3, which is going to be 30, and then square root of 2. And then 22, 23, 24, we'll talk more about negative square roots the next unit. So negative square root of 81. So you could break this up as square root of negative 1 times the square root of 81. Right, the square root of negative 1 is equal to I, which is a complex number. Right, so we got I times square root of 81, which is 9. I times 9 is just 9i. Alright, so then on this one, we have square root of negative 245. So again, let's break this up. Square root of negative 1 times square root of 245. Alright, so let's see what we could break up 245 with. So I know I could divide 245 with 5. So let's see what we get. Alright, so we got 5 and 49. Alright, so we got square root of negative 1, which is I, times the square root of 49 times the square root of 5. Alright, square root of 49, we know that's going to be 7. Square root of 5, that's not a perfect square, so you can't square root that. So I times 7 would just be 7i, and then square root of 5. Alright, so now let's do the same thing for this one. Here, so on this one, so it's the same thing. I'm going to put square root of 145 first, and then let's do, or here, no, let me just do it how I've been doing this. So square root of negative 1 times square root of 145. So square root of negative 1 times square root of 145, multiply to that. Let's see what we could break 145 down with. So I know I could divide it by a 5. So let's see if we divide it by 5, what do we get? Alright, so we get 29. Alright, so let's see if there's something else we could break it down with. So 145 divided by 7. No. Alright, so let's try to find something else. Alright, so 145 you can't really break down with a prime number because 145. Let's see. So this one would just be 145i. Alright, so here's, scratch that. It shouldn't be 145. Should be I square root of 145. Because we couldn't break up the 145, so it just stayed square root of 145. Alright, so now let's go to 25, 26, and 27. This is using the square root method. So if you have something squared, you could square root both sides. Alright, so square root of x minus 2 squared would just give you x minus 2. And then we have the square root of 50. And then we just broke up the square root of 50 up here. That would be x minus 2 equals 5 square root of 2. And again, I just got that from up here because we already broke it up on number 20. So then define x. So to find x, just move the 2 over. So we got x equals 5 square root of 2 plus 2. Alright. So then on, let's see, where am I missing something? Alright, so let's go to 26. So on this one, divide the 3 first. You get 25. Then square root both sides. So you get x plus 4 equals plus or minus 5. Alright, so then minus 4, minus 4. And then on this side, you got 2 cases. You got positive 5 minus 4, then you got negative 5 minus 4. So we got positive 5 minus 4, that's going to give you 1. Then you got negative 5 minus 4, which would give you negative 9. So you have 2 solutions here. You have negative 9 and 1. Alright, then on 27, add the 3 first, you get 8. Multiply 2 to both sides to get rid of that 1/2. You get 2x minus 5 squared equals 16. Alright, now same thing, square root both sides. You get 2x minus 5 equals plus or minus 4. Alright, now on this one you have 2 cases. You have, do this on the and you got 2x minus 5 equals positive 4. 2x minus 5 equals negative 4. Alright, so for the first one, you get 2x equals 9, divide by 2, x equals 9 over 2. Now for the second one, add the 5, you get 1, divide by 2, you get a half. So those would be your solutions, 1/2 and 9 over 2. And so those would be the solutions. Alright, so then, so one thing I was missing on this one was the plus or minus. So it would be plus or minus 5 over 2 plus 2. Alright, so now let's go to the bottom section with the inequalities. Or some of them are inequalities. So find the solutions to the equation of the form f of x equals 0, so when y equals 0. If each table and graph shows quadratic functions, remember solutions, roots, solutions, zeros, roots, x-intercepts. So those are all kind of the same thing, or are the same thing. So on 28, when does y equal 0? It's at -2 and at 3. And so your solutions are at -2 and 3. Alright, so then on 29, when would we have a 0 for y? It would be between, alright, so you would have a 0 here, somewhere in between 7 and -10, and a 0 here. Alright, so your solution would have to be between -2 and -1, or between 1 and 2. So now on 30, your solutions would be right here on the graph where they touch the x-axis. So that's when y is 0. That happens to be at -3 and at 1. Alright, so then let's look at 31. Alright, so the solutions here would be right here. Alright, so one of the solutions falls between -1 and 0. So -1 is less than, x less than 0, and then for the other one is between 1 and 2. Alright, so now on 32, we're going to solve the inequalities. We got x squared minus 11x is greater than or equal to 12. Come on, focus. Okay, there we go. Alright, so we're going to set this equal to 0, so subtract the 12. And then let's factor this. So x squared minus 11x minus 12. The factors would be x minus 12, x plus 1. Alright, so based off this, your solutions, if you set both of these equal to 0, so let's just equal 0, so x minus 12 equals 0, x plus 1 equals 0, so we get x equals 12, x equals -1. Alright, so let's put that on a number line. Alright, these would both be solid dots. Alright, so then where would y be greater than or equal to 0? So we have y equals 0 right here on this line. Everything greater than or equal to 0 would be above the line. So we're just going to be looking at these two branches. Alright, so since the solutions are going to have to be less than -1 and greater than 2, we could write this as x is less than -1 or x is greater than 12. Alright, so that's interval notation. Then for the set notation, you could also write this as -infinity to -1, bracket, union, bracket, 12 to infinity. Alright, so then for 33, again, set it equal to 0, so add the 1, or sorry, add 3. On this one, you can factor out a 3. Alright, then let's just get rid of the 3, so let's divide it to both sides, so just ignore it. So x squared plus 2x plus 1 is greater than 0. So we just divided the 3 just to get kind of rid of it, because it doesn't really do anything here. So now let's factor this. Alright, we get x plus 1 is greater than 0. Alright, so if you set these equal to 0, you would only get one solution. It would be at, let's see, plus 3, yeah. So x plus 1 equals 0, you would get x equals negative 1. Alright, so then you would have the parabola going like this. Alright, so when is everything greater than 0? So this parabola is always going to be greater than 0. If you were to put this on a graph, here, so let's graph this. So we got x squared plus 2x plus 1. Right, so this is always going to be above y equals 0, so this would be all real numbers. Or it's always going to be true. Alright, so for any x value, it's always going to be greater than 0. Alright, so it's always greater than 0, but it's not greater than or equal to 0. So this would actually be all real numbers except for when x is, sorry, when x is negative 1, it's not going to be it. So x cannot equal negative 1. So all real numbers, but x cannot equal negative 1. Alright, so now for 34, we got 2x squared minus 7x minus 4 is less than or equal to 0. So let's factor this. 2x and x. This would have to be negative 4 plus 1. And then your solutions would be negative 1/2 x equals 4. And so here you can just split the middle term and use mental math. Here I just did mental math. Negative 4 times 2x is negative 8, plus 1x gives you negative 7x. So close dots. Right, so everything less than 0 would fall between these two solutions. So this would be negative 1/2 less than or equal to x less than or equal to 4. This was an open dot. Yeah. And let's go to the last page. Okay, so one more thing on this bottom one. So another way of saying all real numbers, not including negative 1, would just be negative infinity to negative 1 parentheses union parentheses negative 1 to infinity. Alright, so it's saying every number not including negative 1. So that's another way to write it. Alright, so now let's go to that. Alright, so on 35, give an example of a perfect square trinomial in its factored form. So an example of a perfect square trinomial, that means both the numbers that would add up, and so add up to the middle, multiply to the last, should both be the same. So here I'll give you all two examples. X squared plus 6x plus 9, that would be a perfect square trinomial, because when you factor this, you would get x plus 3, which is also the same as x plus 3 squared. Another example would be x squared plus 10x plus 25. That would give you x plus 5 squared. So those are examples of perfect square trinomials. Alright, so then 36 says, give an example of a difference of two squares in its factored form. So I'll just give you all two. These are examples of dot problems. So two perfect squares, so like x squared minus 81. If you factor that, you would get x plus 9, x minus 9. Right, then for another example, you could do 4x squared minus 9. This would be 2x plus 3, 2x minus 3. Alright, so it's just a pattern. Alright, here's another example. X plus, let's say, 3 squared minus 25. So these would be two perfect squares separated with a minus. So you would have x plus 3 plus 5, x plus 3 minus 5. And then combine your like terms, you should end up with x plus 8, x minus 2. Alright, so all three of these are examples of dots. Alright, so now for the last one. A rectangular sidewalk is made up of congruent square sections. The area of one of the square sections is x squared plus 8x plus 16. Alright, so that's the area of one square. So if we want to find the length and the width, let's factor this. Again, this is another perfect square trinomial, so you would get x plus 4, x plus 4. Alright, so this would be your length and your width. Right, what is the width of the sidewalk? We just said that, it's x plus 4, and the length, just, so there's 5 of them, so 5 times x plus 4. That would give you 20x, or not 20, 5x plus 20. Alright, so that's the end of the review. Alright, good luck on your tests.